Well, let's get started. Good afternoon, everybody. Thanks for joining us here for this CADRE webinar series. My name is Sharon Yan. I will be your host today. Before we give the spotlight to our speakers today, I'll just to make a few announcements. So first of all, for those not familiar with CADRE, it is short for Collaborative Archive and Data Research Environment. It is a cloud data platform or research environment that we're trying to build. And I'm not going into details here, but you can find more technical information from our website. You can reach us at our Twitter, email as well. We want to acknowledge our founders and data providers, as well as our partner institutions out there. Without their supporters, this would not be possible. So everybody is experiencing a special time right now. And that's why we're hosting everything in a webinar form. Special time calls for special actions. So CADRE cloud infrastructure, we feel we have a special responsibility to answer the White House's call for machine-readable COVID datasets. So we announced this research cohort for study of coronaviruses last week. There's a few confusions out there. So first of all, CADRE is not built to host sensitive patient data, biomedical data sets at the moment. So this is really focused on bibliographic text data. But for those who are familiar with the CADRE Fellowship Program, and this is very similar setup, we are introducing a new data set here, which is curated by a list of entities behind White House's call. These are about 20+ thousand full-text papers. And on CADRE, we also provide additional data set on bibliographic sources, including Web of Science and Microsoft Academic Graph, which include the whole literature. So that's a bigger set than the COVID subset. If you get selected as a fellow team or a cohort team, you also have access to our cloud computing resources as well technical support from our team. And we hope in the future also to invite you to present in the webinar series. So if you are interested in fighting this invisible enemy, contribute your effort through this particular perspective, don't hesitate to apply through this link. So this webinar series has been started back in February, when we launched our alpha version of the CADRE platform. Today is the first installment of the fellow team presentation. Down the road, we have a few more that's in the pipeline. Next up is the team from Michigan State University. They'll be presenting their work on mapping collaborations and partnership in sustained goal development research, which I think is a United Nations program. So that is going to happen on April 29th, 3 p.m. at the same Zoom link. 2 months from now, we have the team from Indiana University and Nanjing University. Yingting, I think, recently moved to UT Austin. That will happen on June 17th, 10 a.m., same Zoom link. So you can find all the related resources about this webinar series, as well as news and events that are happening around the CADRE platform in these places, most of them on our website. So finally, I want to introduce today's speaker. They are both from the Ohio State University. Xiaojing Cai, who is a PhD candidate in Public Information Resources Management at Georgia University, who's actually visiting John Glenn College of Public Affairs at Ohio State right now. I think that's also where Caroline is the chair. So her research focuses on scientific evaluation, government funding, and collaboration in scientific production. So that's more than fitting that today she's going to be talking about accessing the rise of China as a scientific nation. Caroline Wagner has a long list of credentials. I don't think I will go through everything here. I think it's fair to say she has made a major impact in science technology policy analysis, both in academia as well as the public domain. I'll just share a little bit of trivia that happened when they become part of the CADRE fellow teams. They submitted their proposal back in October. I think they're actually one of the latest team to submit their proposal. But when we start planning our webinar series, they're actually the first responders. In a very short time, I think they have a very early head start before they even apply. They already have a draft, if I'm not mistaken. The paper is under review or something like that. And they actually originally planned to do this in person. So unfortunately, given the situation, everything had been switched back to be webinar. But it just gets to show how their research productivity has been moving along. So without further ado, I'll stop my screen sharing here and give a spotlight back to our speaker.
Thank you. Thank you, Sharon. I really appreciate it. And we're really honored to be the CADRE Fellows presenters today. And we're so pleased to be CADRE Fellows. I think we earned our fellowship by being pests and asking over and over again for help with your data. So we really appreciate it. I hope you can see in this presentation that we've been able to put the CADRE data to good use. I should also mention that Xiaojing Chai is, who's going to do most of the presenting, is also a Fulbright Fellow, and she has been studying with us at the Glenn College for the better part of this year, and you'll see a lot of the results of her work. A number of different parts of this presentation are in different papers. Two are well, one is forthcoming, one is published, and then some others are still in the works, and we hope they'll be out soonish. I'm sure everybody in the academic world knows what that's like. So without further ado, let us present our work to you, and we look forward to comments, questions, critiques at the end of that time. All right, Xiaojing, do you want to go ahead and flip to the first slide?
Okay. Is it already the first slide?
No, it's the, that's the cover slide.
Okay.
Okay, great. Would you like to take over, Xiaojing?
Yeah. Hello, everyone. I'm very happy to be giving the presentation here. And now I will start from the introduction part and move on to the result part. Since the 1979, China's policy shift announced by Premier Deng Xiaoping called for an opening of China's science and technology system to the world. China had an existing research sector that primarily provided knowledge services to the national and regional industries, such as agricultural, medicine, and engineering. However, these domestic capabilities were not integrated with other countries, nor did they aim to operate at the world-class levels. Here, we propose that the primary change was one of the public policy towards science and technology in these three ways. First is to become more outward-looking towards the rest of the world, and the second, to better serve domestic industries with higher R&D. And the third is to gain more prestige as part of the international system. In the process of opening up, we see many researchers and students going abroad to learn, cooperate, and share knowledge, as well as to bring back the knowledge to China. And in the process, we ask the following questions. Has China adopted a Western model of science? As China has changed, has it grown more creative? And has China's rise changed the global science? Here are some core literatures related, and we have links in Google Doc at the end of the presentation. Our analyses are based on several sources of data. First is the Web of Science maintained by CADRE, Max Planck, and Insights. Most of our analyses are based on Web of Science data. Second part is the scopers data provided by Bus or elsewhere and the online version. This is used to calculate the total articles of China and to check the mobility parts between China and the US states. The third part is the CNKI. It's the largest database of Chinese articles, and this database is to examine the total articles of China combined with the scopers. And at last, we also include some other studies of China's rise. Now, we will start up by seeing China's rise in the global system. First, to estimate the total articles of China, we sum up the number of non-Chinese articles of China in Scopus and all of the journal articles in CNKI. We recognize that China's work is very much greater than what we see in Web of Science. We will show you how Web of Science participation, but it is only a small fraction of the total volume because most of the Chinese work is published in Chinese and also in Chinese journals. In 2019, there are over 3 million articles of China, but there is only about 500,000, that is a sixth of the total, is indexed in Web of Science. We assume that Web of Science is more international oriented and its work is of higher impact. So here we will explore that in more detail. This figure is to get an idea of Web of Science participation. We can see here the percentage of Web of Science articles in all of China's articles since 2007. Chinese articles in Web of Science are gaining an increasing share. Till 2019, there are about 6% of Chinese work published in Web of Science. Here, we'd like to say the number of Web of Science articles is not a fixed number from year to year, but it does grow much more slowly than the graph would indicate here as part of China's participation. So China is in fact growing in both relative size and also the absolute number of the articles. We then look at China's share of world publication in Web of Science to view the visibility of Chinese work in the global science. Here, fractional counting is also used as a complementary to integer counting, where each country will receive a fraction based on the number of authors whose addresses are in that country. And a country's credit is then allocated based upon the number and the location of authors. We can see that in early 2000s, the main competition for scientific production was between the USA and the EU, and the share of Chinese work is only about 4%. In recent years, China is increasing publications rapidly and becoming a strong competitor. In 2016, its share of publication is much closer to that of the EU and the USA, and is about to surpass that of the USA in 2019, based on the publication in previous years. In fact, in some statistics, this is already a fact that China surpassed that of the USA. On the right graph, in fractional counting, the growth of China is more clear, and the emergence of countries like China leads to the decline of shares of the EU and the USA. In top 10 highly cited articles, this is one measure of the elite articles. There is a huge gap at the early 21st century. During the past years, China is also rising at a rapid rate, from 2% in 2000 to 23% in 2016. China takes up the shares of the US and the EU, and the share of USA declines significantly by more than 10 percentage points. This shows that China is rising in elite status measured at the top 10% highly cited articles. Again, when using the fractional counting, it is more evident that the US and the EU decline more sharply partly due to the rise of China and the intense international collaboration. The same thing applies to top 1%, the decline of US and the EU and the growth of China. To summarize, China is rising in top 1% layer and is squeezing the shares of other nations. As shown in previous slides, China is rising in terms of the elite articles. And on the other hand, China is also rising in terms of the average citation levels from below the world average to surpass the world average and even surpass the EU. Besides, US shows a consistent decline here, and the EU shows a slight increase. By 2018, the gap between China and the other two economies gets smaller and even disappeared. All of the above findings show that China is gaining more and more recognition in the world. China's rising citation impact is evident in not only in all subjects but also in most of fields, except for agricultural, economics, and businesses. The fastest growing of all disciplines are social sciences, mathematics, material science, chemistry, neuroscience, and other fields. It shows that China is making overall progress with work in most fields increasingly competitive. Now we split the articles by national and international to see in more detail, because in different economies, international collaboration differ a lot, as the performance and the quantity of the national publication and international collaboration also differs. From this figure, first in absolute number, the number of international collaboration in China expands the fastest among the three economies, with the most steep line. However, compared to the national publication, international collaboration expands faster in all cases, and their percentage share of international collaboration also increased with time, especially true in the US and the EU. In summary, the share of international collaboration in China is the lowest and grows the slowest in the three economies. However, despite of the low level of international collaboration, growing the international collaboration is quite vital for China's rise in the global system. In this figure, the solid line shows the international collaboration, while the dashed line shows the national publications. First, we can see here the excellence of international collaboration in all economies. It is especially true in China, which shows that it is vital for China to join the international collaboration to raise its overall citation impact. For China, it is international collaboration that makes up for most of its rapid growth of elite articles. As we can see, the share of top 1 or 10% international collaboration group shows the fastest growth, and it largely makes up the poor performance of the national publications. So this result further confirms the success and the efficiency of China's joining the global networks. And then in the next part, we will shift to the network. We want to say more about China's emergence and its strengthening role in the global network. From 2008 to 2017, there are increasing players in the network, and so the network is denser, more complicated, more strong connected here. Among all the players, China is also rising in position and collaboration strength with other countries. Here are the network visuals of 2008 and 2017. The global system is of course changing as a whole. In the meantime, China moved from periphery to the more core position. In 2008, the US is the main core player in the center of the graph, with countries like Great Britain, Australia, France, Canada, Germany, and China in the surrounding. The strongest connections are mainly related to this set of countries. Later in 2017, the network is becoming much denser and with more strong connections among countries. China shows the hugest connection with the US and many links with other countries. There are also lots of links to less developed countries, which most likely resulted from specific policy directives or participation in some health-related research. With them, make the Eagle network based on all China's international collaborated articles. In the Eagle network, we get a more clear view of how China expands and participates in the global network. First, there are more partners linked to China with time. In 2008, there are only 130 partner nations here, and till 2017, there are already 180 nations. Second, the number of links, the average degree, and the weighted degree shows the links among China's Eagle network are much stronger than ever before. The Eagle network is become richer in connections and more strong connected. Third, the increasingly higher density, closer average distance, and higher clustering coefficients, larger K-core groups indicate that partners of China, as well as China itself, are forming a more stable, cohesive, and strongly interconnected community. Here we can see clearly the difference from 2008 to 2017. China is rising in the network and forming a stable collaboration community with its closely connected partners. And here we can see again that China has a strongest connection with the US, and also there are some links to some less developed country, and it is linked with the US and to many European countries and less developed countries that makes the China's position in the global network. Okay, next part is about the creativity. This part is based on the fact that recombination is the source for some parts of new knowledge. It assumes that the recombination is usually based on deeply conventional knowledge and combined with some novelty or surprising combinations. This hypothesis was supported in the work by Uzi and some follow-on studies conducted by other researchers. Here, we will take the same approach to measure the creativity of China's work. Now, I'll briefly introduce the definition of the creativity here. Usually, articles have a list of references, that's a list of reference journals. Any two distinct journals here constitute a reference pair, that is the reference combination in this approach. Using the data in previous years as the baseline, if a reference pair appears more frequently than expected, it is conventional and assigned with a positive score. Otherwise, it is novel and a negative score. Then for each article, sum up the scores of all reference pairs, and we will get a final score for each article. If the score of the article is higher than the grand median of all articles, it is highly conventional. But if the score is less than 10% of all articles, it will be defined as highly novel. In this approach, we will get the 4 categories as shown in the figure, and each article can be classified into the 4 categories. Then we will get a rough view about the conventionality and novelty of Chinese articles, and to what degree are these categories highly cited. Here we'd like to thank Dr. Makuji for his work. As this figure shows, over half of the articles are based on highly conventional knowledge, that is 8% plus 45%. And also there are 20% of the articles are based on novel combinations. Only 8 of the Chinese articles are defined as highly novel and highly conventional, that is creative. According to an existing work, the share of creative article in 2005 is about 7%, a bit lower than what we found here, 8%. This indicates that China is becoming more creative rather than imitative in the process of joining the global system. Similar as the Wooded work, we find that the creative dataset performs the best in terms of the hit probability with a 12% of hit rate, which is much higher than other groups and the world average. In Wooded work, we can see the number is 9.11, much lower than what we found here. Therefore, we'd say that creativity in Chinese work is at a high level and attached to higher hit probability. Next, we will see the creativity in separate fields. First, it is clear the physical sciences tend to be more novel and more conventional, with higher share in the high novelty and high convention group, and it is pretty low in the low novelty and the low convention group. Therefore, it activates the highest hit probability on average than the other two fields. On the contrary, articles in technology are based on the least novel and least conventional reference pair, thus activates the lowest hit probability. But anyway, the creative group, that is the high novelty and the high convention group, are the most highly cited. And on the other side, the low novelty and the low convention group are the least cited.
So we were also interested in using this opportunity of China coming into the global network as a way to understand the network itself as a whole and the participation patterns of different groups. So we did that in several different ways, looking for what's called mimetic isomorphism, which is a big term to describe kind of like more like monkey see, monkey do, which is, an imitative pattern in which the theory is that as a group comes into a larger collection, they tend to take on the attributes and practices of the larger group. And so we tested that in two different ways. One way was to look at a ratio of the percentage share in the top 10% as it's related to the percentage share top 1%. And that's what we're looking for here. In this graph, you can see a ratio of top 10 to top 1%. And we have the three large economies here represented. What you see right in the middle, smack in the middle, is the green dots are all the European Union clustered together over the 16 years. They do not move one way or the other. But the blue triangles are China. And if you start at the lower level, loading on the 10% graph, the 10% slant there, the blue triangles show China's rise in that ratio of 10% to 1%. You can see China beginning at the bottom left in the year 2000, and then at a steady pace, rising up that graph line until it is nearly at the same level as the European Union. In the top right-hand part of the graph, you see the United States, which still loads on the 1% side of the graph. So it's still in having more elite work over time. But what you see in the United States case is the US begins in the top right-hand corner with the year 2000 and moves steadily down the graph. And you can see ending at the year 2016 at the lower level. And we have arrows there to indicate the relative change in position between China and the United States. This confirmed to us that there is an isomorphic pattern among the three groups tending towards the mean that's held now by the European Union. Similarly, we did a measure in which we looked at the likelihood of newcomers coming into the network from China and the extent to which they seek to link to more highly reputed or highly published and highly cited scholars. This was a measure we took quite a long time ago, maybe 25 years ago, of the network as a whole. This is all at the global network level, international collaborations among people from all different countries. And we assume that network is not responding as nearly to a political system as you will find at the national level. And therefore it self-organizes at a more optimal level. And what we see here is that the rise of China and the participation of China in this network indeed falls along the same power law form we found for the network as a whole, studying it as much as 20 years ago. What this suggests to us, again, is this isomorphic pattern. And that is that as the Chinese participants come into the system, that instead of disrupting the system as a whole, what they tend to do is take on the norms and practices of the system as a whole, the social system of the international collaborative network, and become much more like other participants in that network.
Okay, then we will move to see the mobility between China and the US based on the authors of publications. First, it is clear that the number of researchers moving from US to China, as well as the researchers flowing to US from China, are increasing rapidly. The two absolute numbers have doubled in the past years. This gives the first view of more intense interaction between China and the US states. Then we shift to the percentage of Chinese researchers in the US. For example, in this figure, the indicator of 2010 is calculated at the number of Chinese researchers flowing out to China in 2010 as a percentage of the number of active researchers in 2009. Seeing from this figure, compared to 2010, there are more and more researchers flowing from most US states to China in 2018. This flow might probably be the exchange students and scholars going back to China, or some invited researchers who are to work part-time or full-time in China. Also, on the reverse direction, we can see there are more researchers flowing from China to the US again. The flow might consist of visiting researchers from China or scientists and students moving from China to the US for further study and work. The increasing mobility flow between China and the US indicates that there is an intensive interaction between US and Chinese scientific community, which is partly due to the rise of China in the global system, and also this is a reflection of China's rise in the global network. Last, we will focus on cities of China in the global system. Major cities are becoming more fertile in terms of publication, and also they are becoming more engaged in the international collaboration. From this figure, the percentage share of international collaboration in recent years are obviously higher than that in 2008 for most of the cities. It is obvious, especially clear for cities like Xiamen, Shenzhen, Suzhou, Wuhan, Ningbo, that have a low share of international collaboration in 2008. And in the past 10 years, they show a dramatic increase in the share and reach a high level of international collaboration. Another group of cities that are Beijing, Shanghai, Yangling, Hefei, Guangzhou are almost established enjoying the international collaboration in 2008. Therefore, in the past years, they only show a moderate increase. In general, cities are increasingly prominent in the global system from this figure. Then we are going to see the collaboration network among Chinese cities. In 2000, the network shows a lower density and a small core community. There are intense collaboration among the major cities like Beijing, Shanghai, Dalian, Nanjing. The strongest links are almost related to the main players, Beijing and Shanghai only. And in 2017, the network is growing much denser, much cohesive and closely connected, shown by higher density, higher clustering coefficients, larger K-core groups, and larger average degree. Apart from the main players, Beijing and Shanghai in 2008, more cities here are playing a bridging role, such as Nanjing, Tianjin, Wuhan. And also, there are more strong connections in the network. For the next step, we include some major foreign cities here to the network to see the interaction between Chinese cities and foreign cities. In 2008, Chinese cities are mainly active in the domestic range, with cross-country links mainly from Beijing, Shanghai, and Hong Kong. Other cities have some links with abroad, but it is limited here. In 2017, the network grew to be a much denser and highly cohesive and connected community. Here, again, domestic city collaboration are still the main types of links. However, more cities are growing to have more fruitful links with cities abroad. For example, Wuhan and Nanjing are becoming more and more international here.
So to summarize, what we have seen is we started out with the premise that this is a policy shift on the part of China. And indeed, we'd have to say that the policy shift to join the world science and technology system has been spectacularly successful on the part of China. They have also raised their research and development funding also at a spectacular rate. And there are, of course, high correlations between funding and the output of scientific research. As part of that, we've seen their increasing participation in the web of science, the gold standard for the most or the higher quality work in science, and increasing recognition in WOS, although we continue to see quite a significant split between the national research output and international output. International collaborative output, as you could see, is very much at the world level, where the national is still lagging behind. We see China emerging in the global network and participating very actively at the global level, with a very strong connection, of course, to the United States. I would note that the work together with the United States, we guess about 30% of that is actually what we would call China-China collaboration. That is Chinese people, nationals who are in the United States, publishing with people from China. Of course, it's counted as US-China collaboration, but it's actually, there's a lot of China-China in there, which is not unusual for countries that are developing their science system. The work appears to be increasingly higher quality and more creative. And the international work that China is doing is increasingly like other scientifically advanced nations in their behavior and participation. Of course, the question now is, where can it go from here? I think we would have said something different before COVID-19 than we would say now. And I would be interested in what other people think about that. Certainly, we see a great deal of interest now in working with China on the coronavirus research and the many aspects of it, but where China goes from here with their science policy remains to be seen. Thank you very, very much again for inviting us and for your kind attention. We look forward to any comments and questions.
Thank you so much, Xiaojun and Caroline, for your presentation. We have plenty of time for questions. So someone in the audience, please unmute yourself if you want to raise a question.
Hello, this is Guangming from Michigan State. I have a question for this research. Well, how do you guys define what is China's work, China's publication?
So thanks for the question, Guangming. We defined it in several ways. The main way we used when we were working with Web of Science or Scopus data is we used addresses in China. So in that kind of a case, we were able to count by at the national level and also at the institutional level and the city level, what was being published. So it is true that it would be the case that Chinese publication would be significantly beyond that, but we have to use the records that we have. So we were using records based on addresses in articles, notes, and letters in Web of Science and Scopus.
Okay, thank you. How do you deal with the case? I know sometimes a author will put multiple addresses over there. Usually, you know, a author will be, you know, if they have like a, I don't know, multiple like assignments, sometimes they put, you know, both USA and Chinese, you know, China's organization, even, you know,
Yes.
other countries.
Yes, about 6% of articles have authors with the dual appointment, perhaps in the US and in China. So in this case, using such highly aggregated data, it was very difficult to sort that out. So I don't think we dealt with that directly. We only just take that into account in terms of like this 6% the 6% idea. So probably about 6% of the integer counted articles could potentially represent a single person rather than two different people working at two different addresses.
Oh, I see. Thank you.
Thank you.
Yeah, and then that's actually particularly problematic for Web of Science prior to 2008, where they don't have institutional enhancement, where you don't know which one also is affiliated with which address. So yeah, that's kind of difficult you have to deal with. More questions?
Hello, can I have a question? This is Jane from Michigan State.
Yeah.
Hi, nice presentation and thanks for sharing us your research. I'm just interested, you've indicated that you use Web of Science through the Web of Science platform and then through CADRE. So did you see any differences in terms of the quality of the data that you're getting from Web of Science versus getting it from the CADRE platform? And how were you able to address those differences if there were differences? Or
I didn't notice any difference. The data from CADRE seemed equivalent to anything we were able to get. The Web of Science data that we were able to get, aside from CADRE, only came through the web portal. So I would say the CADRE data is much better than the web portal. So, but maybe Xiaojing could talk about that.
Yeah, in fact, the data from the two sites are almost the same. The only difference for me is which one is easy to get. For example, from the CADRE, it is easier to get the data for the collaboration network, for the country counting of countries' publication. Maybe from other sources like Insights and Max Planck, it is easier to get the data of the highly cited using the fractional counting and also get the normalized citation counts. Because using the CADRE now, it is not easy to get the normalized counts here. So yeah, in fact, they are the same data because they are all based on the website submit data.
Okay, all right, thank you.
I'll comment a little bit here. There might be slight differences between the Web of Science web portal to the data that we host on CADRE because we are only getting updated once per year. So the Web of Science group could update their web portal data during the year. So that could be some changes when that's happening.
Yeah, okay.
More questions?
Hello, this is Pei Ying from Indiana University. So I have a question about this mimetic isomorphism. So as far as I can recall, it's from like organization theory, and they distinguish between like mimetic, coercive, and normative isomorphism. And I'm a bit curious about why you choose like mimetic isomorphism in this case. Because although we see that, okay, the trends kind toward the similar point, that means the EU, but usually when we say, oh, this is mimetic isomorphism, that means, oh, we don't actually know what we should do. So we just pick someone we perceive, oh, it's better, and we should go that way. But in this case, do we really think that EU is kind of gold standard in this, like for a global scientific community, or maybe it's because the change of the norm inside the scientific community, so that like people starting to accumulate to publish more and hope to get more citations. And in this sense, it would be more sensible to use like normative isomorphism instead of mimetic one. But that's just my general questions about using the term because I think it had specific meaning.
Yeah, that's a very insightful and interesting question, and it certainly might be worth more conversation. The reason that we looked at it as mimetic isomorphism is because not that we saw that everyone was becoming like the EU. I think that the trend towards the EU is really more a trend towards the mean rather than an isomorphic phenomenon. But the reason we saw it that way is partly, again, this is more of a hypothesis, that as all these universities are being ranked according to a specific ranking criteria, that they are all striving for recognition in a very similar framework. So we saw that framework that is perhaps being imposed from outside the universities to be influencing them to try to be more alike. And that as they try to be more alike, we saw that as more a mimetic, an imitative function rather than a normative function. But I agree with you that there is a normative aspect to it as well. But we saw it more, perhaps more, this is just a suggestion, but it's more like the mimetic trying to look like others over time. The shifting position of China is more easily explained in that isomorphic framework than is the US position. The US drop relative to other countries is not as easily explained using the mimetic isomorphism, but it certainly helps us to understand the rise of China.
Mm-hmm. Okay, got it. Thank you.
We still have time?
Hi, this is Rivka Cook from Indiana University. And I have a question about the measure of creativity, which was basically the pairings of citations. and kind of how frequently those appeared. And I'm curious to know if there are other measures that are used to ascertain creativity, and how this measure might compare to some other ones, especially qualitative measures that might be used.
So this is a relatively new form of measurement. And the other people, there are several other people working in this space. The most notable is Jian Wang at, I believe he's now at Leiden University or Leuven, one of those two. Do you know Xiaoran? I think he's at
Jian Wang.
Pardon, yeah, Jian Wang is
Yeah.
he's at Leiden now. Anyway,
Yeah.
he's done some very, very interesting work on measuring creativity and using a similar approach, but I would suggest you go and look at his work directly. And he's worked with Paula Stefan. I don't know if you know Paula, but they've done some interesting things on measuring creativity. The other group that did some work on it is the Science and Technology Mapping Group, Clavins and Boyack. They also did a similar process using a Monte Carlo simulation. Ours is the one that was developed at Northwestern by Utsi, and including Satyam Mukherjee, who's also on our team. So really, I think all of them harken back to the same theory, and that is this theory of recombination, that new knowledge comes from in part, or perhaps the bulk of knowledge comes from recombination of existing knowledge. I mean, that doesn't account for breakthroughs and discoveries, which are another kind, but that is the bulk of work. And so therefore, if you want to find out about combinations, that one way you could do that would be to look at reference pairs and the likelihood of reference pairs occurring together. So the idea there is then it's very computationally heavy work, because you have to take each article through the Web of Science and match each reference pair against one another, and then the likelihood of those pairs appearing in the articles in a certain field and subfield. So it took months to run that one data set that we did on China. The reason that we use that is because it was validated by the Utsi team, in that they also did this for quite a number of years, over numbers of years, and found that indeed those articles that had this combination of conventionality and novelty together were much more likely to be highly cited papers. And so we felt that the method was validated enough to give us some insight into China's creativity. We did have a very unexpected finding, I will say. We didn't expect China to be that high up in the measure.
That's very informative. Thank you.
We might have time for one last question.
In the chat, Dr. Fry mentions that there's a use, the Aguilar team looked at age of terms to see what new terms were emerging. Indeed, that's another way to look, maybe more in terms of newness or recency. I'm not sure it's necessarily creative, but it's certainly recent. And so that's an interesting way also of looking at this question. And I think we're all just kind of grasping here to try to see, are there measures that can be applied? So these are also, that's another one too. The Aguilar team, it was in the Rand Journal of Economics in 2011.
I have a quick question. I'm sorry if you already answered this. I had to step away just in the middle for a minute. So in my work in Sub-Saharan Africa, I see that an increase in international collaborations results in a decrease in intra-regional collaborations. Did you see this, and what were there any consequences on creativity or sort of high hit publications as a consequence of these declines in geographically proximate relationships?
So this is a very interesting, to me, very interesting question. We didn't look at that in this particular case. I have looked at that in other cases, and I agree with you that you can see that international collaboration does reduce local and regional collaborations to kind of suck people up in the attention economy into the global level, and with a somewhat reduced attention locally. But we didn't look at that in this case, but it'd certainly be an interesting question to apply, and I think we would have the data to do that. As we mentioned in the presentation that Xiaojing also talked about, we see a really, really marked difference between national work in China and international. I mean, they're really almost two separate communities. So that we do note, and that would be much along the line of your premise, Dr. Fry, that the more you become engaged in the international, the more you leave behind kind of local and sometimes national connections. So
thanks. Yeah.
Interesting question.
Thanks very much. Great presentation.
All right, we're running out of time. So please send your additional questions directly to Caroline and Xiaojing through their contact information. And let's thank that excellent presentation again, and thank you for joining us today. We look forward to see you back on April 29th for the presentation from our MSU group.
I put my email in the chat there, wagner.911@osu.edu. Happy to have any comments, questions.
All right.
To that email. Thank you again very much.
Stay healthy, everyone.
Thank you.